In the beginning, a smartphone exists only as a vision, born in the minds of designers and engineers who imagine what the next device could offer. Teams gather in design studios to sketch shapes, select materials, and experiment with colors. They debate screen size, camera placement, and battery capacity, balancing aesthetics with functionality. Once the concept takes shape, digital models are created, followed by 3D printed or CNC milled prototypes that allow the team to hold the idea in their hands. Engineers then begin the painstaking work of fitting the electronics inside, mapping out how each component will interact, and ensuring that performance targets are met. Early prototypes are subjected to an array of tests, drop simulations, water resistance trials, button endurance runs, and wireless signal measurements, so that any flaw is discovered long before mass production begins. Only when the design survives this rigorous scrutiny is it approved for the factory floor. The journey then shifts to sourcing the critical parts that will give the phone life. The heart of the device lies in its chips: the processor, memory modules, image sensors, and communication systems. These are crafted in some of the cleanest environments on Earth, semiconductor fabrication plants. Inside these immaculate spaces, wafers of ultra-pure silicon are transformed through dozens of complex steps, including photolithography, etching, and ion implantation. Layers of microscopic circuitry are built up, each aligned with nanometer precision, until billions of transistors sit on a slice of silicon smaller than a fingernail. Once the circuits are complete, the wafer is cut into individual chips and encased in protective packaging designed to shield them from damage while enabling high-speed connections. Modern advances, like wafer-level chip-scale packaging, allow these components to be even smaller and more efficient, freeing up space inside the phone for larger batteries or new features. Meanwhile, other suppliers produce displays, batteries, speakers, cameras, and the tiny motors that make haptic feedback possible. These parts are shipped to massive assembly facilities in manufacturing hubs like China, India, and Vietnam, where the real construction begins. Here, hundreds of stations line up in long rows, each dedicated to a specific task. Robotic arms place chips onto circuit boards, precision soldering machines secure connections, and skilled workers install cameras, screens, and buttons. Every step is designed for speed and accuracy. Some workers repeat the same action hundreds of times a day, each movement honed for maximum efficiency. At full capacity, a single plant can produce hundreds of thousands of smartphones every day, with devices moving steadily down the line in a carefully choreographed flow. As the phone takes shape, engineers introduce innovations to make it sleeker and more capable. Some manufacturers now replace traditional solder balls with copper posts and chip packaging, reducing the thickness of the assembly while improving heat management. This space-saving approach not only allows for thinner phones, but also opens room for more advanced hardware. Once all major components are assembled, the device is powered on for the first time. Specialized software runs diagnostic checks to ensure every feature works exactly as intended, from the touchscreen sensitivity to the accuracy of the camera's autofocus. After assembly, each unit undergoes a battery of quality assurance tests. Machines drop devices from controlled heights, press buttons thousands of times, and submerge them to verify water resistance claims. Climate chambers expose phones to extreme temperatures and humidity to ensure they can survive diverse environments. Any unit that fails is sent back for repair or recycling. Those that pass move on to the final stage. Packaging lines are a blend of automation and human oversight. Robots fold instruction manuals and place them in boxes, while workers insert accessories like charging cables, power adapters, and SIM ejector tools. Each phone is carefully wrapped to protect it during transport, then stacked into larger cartons bound for shipping. Warehouses buzz with forklifts as pallets of freshly made smartphones are loaded onto trucks bound for ports and airports. Some will travel across oceans by container ship, while others will be flown directly to meet urgent market demand. Within days or weeks, the devices arrive at retail stores or distribution centers, ready for eager customers. In recent years, sustainability has become a major focus for these operations. Many factories now run on renewable energy, recycle water used in cooling systems, and recover valuable materials from defective units. Brands are also working to streamline packaging, using recyclable materials and reducing plastic waste. Global supply chains, once heavily centralized, are diversifying to reduce risk from disruptions like chip shortages or geopolitical tensions. Sophisticated tracking systems now monitor every component's journey, ensuring that production lines keep moving without costly delays. The future promises even greater changes. Advances in automation could allow factories to build more complex devices with fewer human interventions, while artificial intelligence could predict equipment maintenance needs before breakdowns occur. New materials, from foldable glass to biodegradable plastics, may redefine what a smartphone looks like and how it feels to use. As production techniques evolve, the time between concept and launch will shrink, and the devices themselves will become more powerful, durable, and environmentally responsible. From the first spark of an idea to the moment the finished phone lands in your hand, the process is a symphony of creativity, engineering, and precision manufacturing. Every swipe, every call, every photo you take is made possible by countless hours of planning, building, and testing. An invisible journey that turns vision into reality. The story of how a smartphone comes to life doesn't just end with the final assembly and packaging. In fact, the journey inside the factory is much richer and more intricate than most people ever imagine. For example, deep within the production lines, there are specialized sections dedicated to creating parts of the device that are often overlooked, but critical to its operation. Take the antennas, for instance. Modern smartphones have multiple antennas, one for cellular communication, others for Wi-Fi, Bluetooth, GPS, and even NFC. These are carefully embedded in the phone's frame or hidden beneath the back cover. Engineers must ensure that these antennas are placed in such a way that they avoid interference from metal components or from the user's hand when holding the phone. In some facilities, sophisticated electromagnetic testing chambers are used to measure signal strength and fine-tune placement, ensuring that every call, video stream, and map navigation session works seamlessly. The same level of detail applies to the phone's microphones and speakers. The microphones are tuned to capture clear audio even in noisy environments, often using multiple mic arrays to cancel background sound. Small openings are precisely drilled into the casing to allow sound in without compromising water resistance. Speakers, on the other hand, are tested for clarity, volume, and durability. Tiny variations in the alignment of speaker membranes can have a significant impact on the sound quality, so these parts are often examined under microscopes before being installed. In some high-end facilities, audio specialists even conduct human listening tests to verify the sound profile, ensuring that music and voices sound natural. Then comes the camera system, which has grown into one of the most competitive areas of smartphone design. A single flagship phone can have multiple lenses, a wide angle, an ultra-wide, a telephoto, and sometimes even a dedicated macro or depth sensor. Each of these lenses contains precision ground glass or plastic elements, often assembled in dust-free rooms to avoid any tiny particles that could appear as blemishes in photos. Image sensors, which capture light and convert it into digital signals, are bonded to the lenses using advanced adhesives that cure instantly under UV light. Once installed, the cameras are calibrated using test charts and specialized lighting setups, ensuring that colors, focus, and stabilization all meet strict standards. Every adjustment is measured to the pixel level, because in today's market, a camera's performance can make or break a smartphone's reputation. Batteries, too, require extraordinary care in both production and installation. These lithium-ion cells are powerful but sensitive, and any damage during manufacturing can cause long-term issues or even safety hazards. Before being inserted into the phone, each battery is tested for capacity, charge retention, and internal resistance. Modern facilities often use robotic arms to handle batteries, minimizing the risk of punctures or bends. The battery is then secured within the phone using strong adhesive strips, but these are designed in such a way that they can be removed safely during repairs. Safety testing follows strict global regulations with thermal, pressure, and charging cycle tests simulating years of usage in just a matter of days. The display, often the most visible part of the phone, is another masterpiece of engineering. Whether it's an OLED or LCD panel, each screen is manufactured to exacting tolerances. Pixels are arranged in microscopic grids, each capable of emitting or blocking light in precise amounts to create vibrant colors and sharp images. The touchscreen layer, a transparent sheet of electrodes, is bonded directly to the display to improve clarity and touch responsiveness. This bonding process, known as lamination, must be done in a dust-free environment because even a single speck of dust can create visible defects. Once laminated, the display is tested for brightness, color accuracy, and touch sensitivity, with robotic fingers simulating swipes, taps, and multi-touch gestures. One of the most fascinating yet unseen processes in the smartphone factory is software flashing. This is when the phone's operating system is installed onto the internal storage. Specialized machines connect to the phone's ports and transfer gigabytes of data in seconds, writing not just the OS, but also diagnostic software that will later be used for testing. Once the system is in place, the phone is booted up for the first time, and automated scripts run through a checklist of functions, making calls, connecting to Wi-Fi, taking photos, playing audio, and more. This ensures that every unit leaves the factory in full working order without defects in either hardware or software. Beyond the core hardware, accessories are also given attention. Charging cables are tested for flexibility and durability, plugs are checked for secure connections, and SIM ejector tools are inspected to ensure they meet the manufacturer's design standards. Even the boxes are precisely measured so that they fit the contents perfectly while providing enough protection during shipping. In luxury models, packaging becomes part of the brand identity. Thick cardboard, textured finishes, embossed logos, and clever folding designs all add to the customer's unboxing experience. Once everything is packed, logistics teams coordinate with shipping partners to send phones across the globe. This stage requires careful planning, as smartphones are high-value products that must be protected from theft, damage, and environmental hazards. Temperature-controlled storage might be used for certain sensitive shipments, while GPS tracking devices in pallets ensure that their location is always known. Customs documentation is prepared in advance to avoid delays at borders, and shipping routes are selected for speed and cost efficiency. In many cases, phones destined for major markets are shipped in bulk to regional distribution hubs before being sent to individual retailers or directly to customers. Inside the factory, the atmosphere is a mix of intense precision and relentless pace. Machines hum in the background, conveyor belts roll steadily, and workers move with practiced efficiency. Every person on the floor has a specific role, and their contribution, no matter how small it may seem, is essential to the final product. Quality inspectors walk the lines, pulling random units for additional testing, while maintenance crews ensure that equipment stays in top condition. Even a short breakdown in one part of the line can have a ripple effect, slowing the entire process. In parallel, research and development teams often operate within or near these manufacturing sites, experimenting with new assembly methods, materials, and components. They might test a new type of adhesive for better water resistance, a more efficient heat spreader for cooling high-performance chips, or a novel antenna designed for faster wireless speeds. Their findings often lead to mid-cycle improvements, meaning that even within the same phone model, later production batches may be subtly better than the earliest ones. Looking ahead, factories are rapidly adopting smart manufacturing systems powered by artificial intelligence and the Internet of Things. Machines equipped with sensors can send performance data in real time to AI algorithms that predict potential failures before they happen, preventing downtime. Augmented reality tools are being tested for assembly line training, allowing workers to see step-by-step instructions overlaid on their field of vision. Robotic systems are becoming more flexible, capable of switching between different phone models with minimal reconfiguration. These advances promise to make production faster, more adaptable, and less wasteful. Sustainability will also continue to shape the future of smartphone manufacturing. Companies are experimenting with recycled aluminum for frames, bioplastics for casings, and eco-friendly dyes for coloring. Energy use in factories is being reduced through LED lighting, optimized HVAC systems, and the use of on-site solar power. Water used in cleaning and cooling is increasingly filtered and reused, reducing environmental impact. Even end-of-life devices are being dismantled in automated recycling facilities to recover rare metals like cobalt, lithium, and gold, feeding them back into the supply chain. It's easy to forget as we scroll through our favorite apps or take photos with a quick tap that these devices are the product of a massive global effort. Each smartphone represents the combined labor of thousands of people: designers, engineers, technicians, assemblers, logistics experts, spread across continents. It also represents decades of technological progress, building on countless innovations in material science, electronics, and software engineering. The sleek rectangle in your pocket is, in many ways, the modern world distilled into a single object. From the spark of an idea in a designer's mind to the last check in a quality control station, every step in the process is deliberate. Every component, no matter how small, is chosen and tested with purpose. Every connection is saucered with care. Every line of code written to ensure the experience is smooth and reliable. And after traveling thousands of miles from factory to store shelf, the phone finally reaches its new owner, ready to become an extension of their daily life. When you unbox a new smartphone and power it on for the first time, you're holding the result of a journey that spanned the globe, crossed countless hands, and demanded extraordinary precision. It's more than just a device. It's the culmination of human creativity, engineering brilliance, and manufacturing mastery. Behind its slim profile lies a world of processes, innovations, and hard work that most of us never see. And yet, every time you make a call, capture a memory, or explore the digital world, you're connected to that hidden story, a story of how vision becomes reality. As devices roll out of the factory and into the hands of customers, feedback loops begin. Reviews, performance data, and repair reports from the real world are sent back to engineering teams. If any recurring issue is found, production lines can be modified to prevent the problem in future batches. In some cases, this process is so fast that phones produced just weeks later already incorporate subtle fixes based on early feedback. It's a reminder that a smartphone story doesn't end when it leaves the factory. It continues to evolve as part of a larger ecosystem of improvement. If you enjoyed this deep dive into how smartphones are made and want to explore more behind-the-scenes stories of the technology we use every day, make sure to hit that like button, subscribe to the channel, and turn on the notification bell so you don't miss our next video. Share this with a friend who loves tech as much as you do, and let us know in the comments what device or process you'd like us to cover next. Thanks for watching, and we'll see you in the next one.